Hey YouTube, it's Petey, and right now I'm testing my work that we did yesterday. So this is the amplifier I've been working on. These are battery trays. Here's the power amp section, and then here we have a 7809 voltage regulator. So the job that does, this here battery pack is just for the circuits, the preamp and what have you. So this is 12.5 volts here with those three batteries in there. So the 12.5 volts goes to this switch, and it comes out and hits this voltage regulator, which is a 7809. And that means it converts 12 volts to 9 volts. So there's a heat sink on it and a couple of capacitors for smoothing and ripple and filtering. That 9 volt rail is here. There's bottom one is negative, the top one is plus, and then there's two circuits here. There's one with the chip that's a op amp, and that's a buffer. That's the buffer out of a Klon pedal. It's supposed to be a good buffer. And then this is what's called a fetzer valve, which there's the J-FET for it. Here, there's two adjusters on it. The one is for the bias, and then this is a volume control. So what I did today, I clipped this 12 volt battery with these test probes onto where the batteries connect to test my work. And the final thing that I ended up with was this wire, which is this is a shielded cable. I'm using shielded cable on all of the audio runs. So anytime there's audio in this amp, it's not just a wire, it's a shielded cable, and that's going to help keep it from humming. Like, see if I can get this to hum. It's difficult to pick up the hum, but and that may be because of my use of shielded cabling. Now, the idea with the buffer is it compensates for your cable. Like if you don't have the buffer there, it's a lot more impedance. There's more of a load, and your cable has some capacitance, so that acts as a filter and it cuts off the high end. So it's just like having true bypass pedals and no buffered bypass. Every one of those connections is more resistance and more impedance, and that weighs down your signal, puts a load, and kills some of the sparkle. So putting a buffer in at the front of the amp is one way to make sure that you have clean signal. It doesn't boost it, but that's the job of the second stage, the fetzer valve. This is like Fender fetzer because it's an FET. It's a single N-channel J-FET that's biased to 4.5 volts. And the original design had a potentiometer for the volume control. I used this trimmer because more than likely I'm going to set it in one spot and never mess with that. And I'm trying to reduce the amount of controls on the front panel of the amp. I don't want it to be covered in knobs. I mean, that looks cool, but for functionality, really I'm going to be trying to set this up and just toggle between clean and dirty and not even use a master volume. That's what I'm going to try to do. If I decide, well, I really could use a master volume, there's one of these trim pots is on this board, the amp board, so I can remove that or just cut it out, clip it out, and solder onto those posts with 3 wires and run those neatly around to the front to a pot, 100K. Actually, it's a 10K pot. That's what's in here is a 10K trimmer. So I would use a 10K logarithmic, which is an audio taper. And that just gives you a smooth kind of feeling when you're running the pot, how it responds to where you turn it. They have logarithmic, reverse logarithmic, and then linear taper, and they all feel a little different how they respond to when you turn them. So what I wanted to demo real quickly is, all right, this amp is a 5-watt chip amp that's run on a 4-volt battery. And it's supposed to take 5.5 volts. It's on 4, and it's kind of a deader battery, so that's all we're getting out of it. But yeah, it sounds good. This sounds pretty good for what it is, for a homemade amp. Sounds pretty good. And what I wanted to say, yeah, it sounds pretty good. So let's eliminate these circuits. We're just going out of my guitar, right into the amp, and see what we get. Put it on half volume here. Okay, that's just the amp. Now let's cut in my buffer and the fetzer valve so we can hear exactly what that's doing to my signal as I knock the shit out of my guitar. So as you can see, it's giving it a little bit more sparkle on the high end. It's giving it goosing it with some dBs. The circuits that need to be cut in here is a Le Louis, which is a Fendery. It does like distortion. I modified that to be much cleaner. When you crank the gain, there's a little bit of pleasant breakup. And then an Angry Charlie. That's a Marshall, like a high gain Marshall in a box. I also got a noise gate that I'm going to put in there that's going to go on just on the distortion side. So those three circuits need to get cut in here. I checked my rail coming off of this V-Reg, and I'm getting 8.92 volts, which is exactly what I would expect. So I got to get back to this and cut in an output jack. Gee, where is that gonna go? Oh boy. Maybe I'll put it in the middle here, in between these two. So yeah, that's going to require some thought. There's just wherever you put something, it's going to get in the way of connecting the battery. So I've got to figure that out. Maybe I can squeeze it underneath here. Maybe it'll go underneath where the fuse holder is. That's probably the best location. All right, you guys, I'll see you soon. Talk to you later, and peace.